Alrighty, so here I'd like to look at regression. Okay, and a categorical variable. Okay, for explanatory. So previously, if we had something like this, we would use an ANOVA, but we want to look at this with regression, and so right now we'll just assume two categories or two levels. Okay, so we just have two categories, so we might have data, and I'll do a spreadsheet with this as well, but you know, we could be looking at, say, petal length, and there's a famous data set of iris species, and we'll just use two of them to get two categories. So we'll have an iris setosa. It's one particular iris. And our other iris is versicolor. So iris versicolor. So you might have data like this and different lengths. So, you know, petal length of like, you know, somewhere in the 1.4 range, 1.5, that sort of thing. And the versicolor has longer petals, and, you know, so maybe 4.5, 4.7, and so forth. Okay, so you'd have those down. Well, what we're going to do is actually, for a categorical variable of two levels, we're just going to have petal length. Okay, so petal length as our y, but over here we're going to have, I guess, species. Well, we're going to use what we call a dummy variable, and so our actual species maybe is setosa. I had to look back to make sure I had that spelled right. You know, so I might have a bunch of setosas to begin with here. And then some versicolor. So these are the actual species right here. So, you know, we have something like this. And again, the setosa had the shorter ones, and, you know, so maybe that was, you know, 1.5, 1.7, 2.0 maybe. And then the versicolor, you know, 4.5, 4.8, 4.7, you know, something like that. Now, what we'll do for the species, so this is our y value is petal length, but our explanatory variable, whoops, hit that. Oops, wrong thing. Okay, here we go. Our species, we want to use a dummy variable, and it doesn't really matter which one of these two I use, but I'm going to use a 0 for the setosa and a 1 for the versicolor. And that is the way I'll make my x values, and this is how I will run my run my regression. And actually what's going to happen is when I do this, right, I'll get y equals some mx plus, well, we're using bx plus a. So I'll get some slope b. And actually, the amazing thing here is that a, when we do this, if I'm using 0 here for the setosa, a is going to equal the average for setosa. Okay, so your intercept just turns out to be the average value for the setosas. And then the slope here, b is going to be the versicolor average minus the setosa average. And so b is going to be the difference in the averages, and then we can still compute our p-value based on the hypothesis, right? The null hypothesis, H0, hypothesis is that b equals 0, right? In other words, the two means are the same. Well, that's the same thing as ANOVA, right? That the two means are the same. So, you know, x bar v is equal to x bar s. That is H0 for ANOVA. So actually, we see in this chapter anyway, that we can, if we just have a two-category analysis of variance, we can actually use regression to get an answer. And our alternative, of course, is that b is not equal to, b is not equal to 0. So just like the ANOVA, right? So HA is just like the ANOVA. Now I'm not writing down what that is, you know, for the ANOVA, right? It's that the means are the same. X bar v is not equal to x bar s. Okay, so that's our alternative for the ANOVA, and that is exactly the same alternative we're getting here for the regression. So in the next video, we'll actually put this into a spreadsheet with the data and see that we do indeed get that A is the average for setosa and B is the difference in their averages. Now, if we swapped the zeros and the ones, it would be the opposite. A would be the average of the versicolor, and then B would still be the difference, but again, it would be the negative. It would be the average of setosa minus the average of the versicolor. Okay, so that is what we can do with a categorical variable with two levels. Okay, so just two categories. Now, in the next chapter, we'll see we could actually do this for as many categories as we want. So that's nice. So we can actually solve an analysis of variance problem using regression. But we'll have to learn a little bit more about regression in the next chapter to solve any of the such things. Okay, so we'll call that one done.